In a galactic man, in a galactic woman. Okay, so here we're trying to calculate the activity of a pure 7 or 9.7 microgram sample of phosphorus 32. And we know the half-life is 1.23 times 10 to the 6th seconds. So how do we go about doing this? Well, first, this is going to be kind of weird. I know for the activity, I need to find lambda times n, where n is actually a number of nuclei. So I don't want a mass, I want a number. And this means I got to remember a little bit of chemistry. So what I have to do here is I have to say that 9.7 micrograms, so 9.7 times 10 to the minus 6 grams here. This we could train track or fence post or dimensional analysis. We need to convert that into moles. But we know that 1 mole of phosphorus 32 is, we're just going to say this is 32 grams per mole, like that. So our grams go away here. And then what we need to do is multiply by Avogadro's number. So that's our 6.022 times 10 to the 23rd atoms or nuclei per mole. So now the moles go away. We have things in terms of atoms or just n, the number of nuclei here. And what we find is that n should equal for us somewhere around, a little bit of rounding, 1.82 times 10 to the 17 nuclei. Okay. At this point, we just need to find what this lambda value is. One of the things to remember is that lambda, and we saw this in a prior setup, is lambda is equal to the natural log of 2 divided by tau, or the half-life, where this half-life is in seconds, and luckily it already is in this problem. So we can say this is 0.693, or if you're dealing with economics, maybe just 0.7. And then divided by 1.23 times 10 to the 6th. That'll give us our lambda value. And when we take this lambda value and we multiply it by the number of nuclei here, boink, we will get our actual activity of our sample, which is 1.0 times 10 to the 11 decays per second. Okay? And whenever we have decays per second, we're really just measuring a count right there. So it's how many counts we have of these decays per second. So nothing too crazy in this problem. Just a little bit of old school chem coming back to haunt us. And then once again, using this activity equation and finding lambda from tau. Okay? So with that, this problem is finished. Until next time, adios, and take it easy, my intergalactic brethren.